Okay, so in our previous session, we discussed about the fundamental of the games programming or games modeling. So in this session, I'll briefly discuss one more example on the games. Then I briefly discuss the next software. So as we know, in a power system, where is the one very common problem or very basic problem is the economic load dispatch, or as electrical uses to it, all we are aware about this economic load dispatch problem. And we also know about the conventional method to solve this optimization problem is the lambda iterative method. So in lambda iterative method, just we define one Lagrangian function, then we can differentiate and find out the equal and incremental cost, the same value of the lambda. So if the value of the lambda is known, then that value we can find out their optimal values. So this is the algorithm for the lambda iterative method. So by iteratively we can solve and find out the optimal value. But this algorithm is only applicable or working good for the very smaller system. We have a few number of generator. If the very large number of generator, then it's take the very last time and sometimes it's fail to converge. Or very limited number of the constraint also. So we applied this for example point because I made this PPT for my UG student or for the very fundamental basics. So I'm not considering very large problem here. So very simple three generators, one B matrix, one demand, and we can solve this problem by using the lambda two method in the game in a MATLAB. And same problem we can model in the games and solve by using the games. And we got these optimal values. So the red color is the MATLAB, and the black one is the GAMS with and without losses, and the different demand also 120, 150, 170 megawatt, and their optimal power output of generator 1, generator 2, and generator 3, then total cost and the simulation time. Because this is the very smaller system or very so simulation time in the very last within seconds, or if you in the MATLAB, the simulation time it depends on your initial value of the lambda. If you choose the value of the lambda is very near to the optimal value, then it converges in the very last minimum iteration. If you choose the initial value is very far from the optimal value, then it's take the so large number of the iterations. So simulation time is not a fixed for the MATLAB. It depends on the initialization of the lambda value. But quantity is very in the second, so not significant at the time. And like for the multiple periods, then further we just upgrade. We can consider the ramp limit of generators. Then same program we can modify it for the four number of generators, consider the ramp limit also, ramp up and ramp down for the different load values. And we can optimize, we find out the optimal scheduling of generators for the given load profile. And we also discuss the same games code for the optimal power flow. One of the very these three books, I have the soft copy of these books. If you require, I also say it. So fundamental modeling, basic modeling, you can post optimization modeling in the games by the author Ali Raja Saruti. This book is very helpful to understand the basic application of the games in a power system problem. This book include like equipment load dispatch, unit commitment, optimal power flow, both AC and DC, uh, uh, optimal capacitor allocation, optimal storage allocation problem. I think some plumbing problem is also there. And games also have that tool. Same book code also available on the games website. You can go. You can see here. You can go to the games.com and go to the documentation section, games, and you can see the model libraries. So here you can see the last one is PS OPT library, the power system optimization. So same book. All the codes used in the this book are available on the this website. Simple energy, some new addition also. Current load dispatch, unit commitment, optimal power flow for the 2 bus, 3 bus, 5 bus system. You can see open here. Same codes are available. So this is very helpful to understand the basic modeling of the power flow, basic uh, the modeling of the power system problems. These codes are very helpful. Same mathematical formulation you can read in the book, and similarly code you can see here. Example code is seen here. So it's very helpful to understand how we can write the different equations, different conditions in the games. And one more important thing I forgot to explain, that is in the games there are two important function. That is, first one is the one function is the ORD, and one is the card. Suppose your set A have the elements 1, 2, 3, and 4. So if you use the OR statement, or A, so it gives the value of their location, their values 1, 2, and 3, and 4. But if you write the card A, then it show the total number of the element, that is 4 only. So these odd and card are helpful to write the conditions. Suppose I want to execute particular set, particular equation for only the set 1. So for that one, I can write the equation, for example, equation 1 A, and I want to execute this equation 1 only for the set A 1. So I can write the dollar ORD A EQ for equal to sign, or directly you can use the equal to sign here now. But earlier they use the EQ 1. So now this equation only execute for the 1. If you want execute for the 2, so you can write the 2 here. So these two function also are very helpful in the games coding, odd and the card statement. Okay, so this is about the games modeling. I'll share this PPT, and if you require the soft copy of these books, I also can share. So you can understand the games, programming, game syntax by using these books. Okay, now let me briefly discuss another tool, another software, that is R. So R is a statistical software. It's open source, not any license we required. So R is the open source software to do the statistical analysis, statistical modeling for the different application or different field. So brief introduction of the R. R is the free software of statistical computing and the graphics. And this software is very similar to like a Python. What are the main feature of this one? It's the open source, that is the main advantage. Freely available packages are there, so many libraries are there. It can be easily interfaced with the all operating systems. Graphics facility are very rich facilities it provide, and it is used by the many software companies like Google or Facebook. They are using this software for the statistical computing. And this software You can download and you can run your own system, or it is also available in the cloud platforms. Again, like games, there are two versions. One is the basic R version, and another is the Games Studio. But Games Studio, sorry, R Studio. R Studio is the more user friendly as compared to their base version R. But to run the R Studio in your system, you have to download the R software, then you download the R Studio. So for the download this R Studio, you can go to the website. For to download the R, you can go to rproject.org, and for the R Studio, you can go to the website rstudio.com. And this R Studio also available on the cloud platform, their own cloud, that is rstudio.cloud. So no need to install the R Studio. That simply open in your browser, web browser, or you can write a code and you can do the programming. But as a free user, they provide some limited space. They not provide the full access of the memory or the large computation facility. They limited space they provide. But if you purchase the cloud space, then they provide the full version. Also, this R Studio, that is also same like your desktop. It is available on Amazon Cloud Services. That is AWS. So if you not have the very high its computational facility, you can use the cloud services, and you can do the pure coding, and you can make the large application on the cloud. Now this is the layout. This is the layout of the R Studio. There are four sections, or like it look like similar to the MATLAB, but there are four sections. First one, the source. This section we can open the new file and we write our own codes. Then the console and terminal jobs, we have the execution. If you run the particular code, then output will be shown in this terminal or the console window. Third one is the environmental or history. Any defined variable, their values, their type, it will be shows in the this section, environment or history section. And the fourth one is the file. If you use any plot, packages, help, and the viewer. Now, the programming in this R platform is almost similar to the Python programming. In this type of the platform, if you don't want to develop any your own packages, so you have to download the libraries. Libraries called the packages here. So you can download and install the packages, all the particular packages, then you can use accordingly according to your requirement. Now, these are the some. This is the some I'll discuss. There are different icons. What are the meaning of this one? I'll discuss only the important one. This is for the run icon. In environmental section, this import data, directly import from the Excel file. History of your command, fast command history, memory uses. Tutorials are very number of tutorials are available on their RS Studio website, and you can see here. Yeah, this is important. How we can download and package this, package the download the particular required package. So there are, you can click on the packages. You can see here this one, packages here, and there are installed package option is there, or like some packages are not available here. So directly GetUp, if you are using, so by using the GetUp you can download and install the package directly, or you can browse here. There your installed packages are shown in this list. Now plot also, this is the multiple plots are there, so it's an aggregation, arrows are there, zooming, export the plot in multiple format, JPG format, TIFF format, EPS format, you can export. And other thing is okay. Now For the basic starting, how we can define the name or particular assign the values, particular operator creating the object. So suppose I want to define a equals to 10. Suppose we want to define a equals to 10 in this R studio. So how we can write? We can write a less than sign for the import, assign the value, then hyphen, then 10. So this is the syntax to assign the values or assign the any operator in the R. Similarly, you can define the character also any type. So like the values and the character you can define here. Like suppose I define B is inverted comma B for the ball. So it show in the same. It show the environmental tab. A equals to T D and ball. It's there are change also. It's a list format, or if you want to show in the grid format, you can change here list to the grid. Now this is the common rules sort and informative. Generally, they defined as like a underscore dot. Mostly, we are preferring this type of a syntax. Dot, you have to avoid special character. You have to avoid. Don't type the true or NA as your name of your objectives. Objective function name is not same as your inbuilt functions like mean value, average value, standard deviation. Yeah, this one is important. Now, suppose I want to create one vector that have the multiple values. So how we can create in the this R studio? You can use the C function, C for the combine, or short for the concentrate. So like suppose I have 2, 3, 1, 4, 6. These are the elements in the array. So I can use define my vector input C for the combine this one. Now return multiple sequence and repetition we can use 1 to 5. So we can use the sequence repetition 2 for the 10 time. So we can do the repeat function. Yeah, this is also important. Suppose sometime in the data set we have some missing values. So there are like a missing data that is by the NA not applicable or some other side. So if your data set has a missing value, then suppose you are calculating the mean value or some you can perform some only mathematical function operation, then it shows the output as the NA. So how we can avoid this type of the missing value? How can separate the missing values? So for that one, we can suppose you want to calculate the mean value of this temp variable, temp parameter. So we can write the mean temp this array.rm equals to true. This statement we can write to separate out or elevate this NA values. So we get the mean value of this array. If you directly use the mean, then you can see it show the NA, not applicable as the output. So this is very important feature. Now different data types, all similar to other language, numerical, integer, complex. Yeah, data we can use the vector matrix array data frames, different columns are there, list all the data set in the same, so they can for the list. So these are the different format. Suppose I want to create one matrix that have 1 to 16 element 4 row. So I just gonna type matrix 1 to 6, number of the 4, row the 4, so you can see output. Different dimension you can change, like dimension is 2 4 2, so we can break it to matrix. We can assign the the names, row names and column name. So row name you can see column name ABCD, row name ABCD. We can define like this one. Transpose, you can use the D for the transpose. Yeah, in the list file, we have the like a character values also, the matrix also, all these things. So we can see here, list black, yellow colors are there, true false logical statements are there, matrix also there, all they are defined as a list. Same data frame, we have the different data set like the height, weight, names also. So that defined as a data frame. Conditional statement same like other languages, only syntax are different, almost same. Yeah, reading of the data, it's very very easy in the R. But for the reading of the data, first you have to install the read R package. So first you have to go to the package option, click just I show the demos. Yes, to install the packages, you can go to the tools, install packages. So you can type the few letter of the package name, and then you can install. And similarly, you can click here the packages here, or click on install the package. Here it show the list of packages already installed in your system. So to read the data from the Excel file, first you have to install the read R package. Then you can use this syntax. So text file read dot table, write dot table, read CSV file, write CSV file, dot R data file. So these are the syntax to read and write the data from mostly via the CSV file. Now this is the static and like similar to the Python and nowadays used for the multiple applications. But we are use this software for solving or for developing forecasting model for energy forecasting. So we are developing the like a machine learning models or some time series model for the load forecasting, for the price forecasting, for solar and wind power forecasting. And we are using because our model has some complexity, shows some complexity, so we are using the cloud platform like Amazon AWS for the coding. But for the simple, very simple smaller system or some very less data set, we can directly use our own system like my laptop and uh, our studio. So as we know, briefly I discussed the forecasting problem. We know the forecasting is just like we are making the predict. We are just forecast the future value by using the historical observations. Depending on how what value we are forecasted, simple one step, two step, or n step forecasting. Suppose this is my historical data, and by using the historical data, I can develop one model based on historical data, and by using this model, I predict the forecast the new values. So we only forecast a single value, then it's called a one step forecast. two values two step forecast and new values, so that is the n step forecast. Normally, depending on data resolution, generally data are with the different resolutions: 1 minute, 10 minutes, hourly, 30 minutes. Our power system, our country, mostly data are like demand data, price data. They are available in the 15-minute horizon, in the 50-minute time span. One more thing I show. Yeah. Uh, yes. Now there are different form of the forecast. Like if you forecast only the single values for the next time, the lead time, that is called the pointed deterministic forecasting. If you forecast the like a different quantiles, considering the error also in the prediction, so that is part of the probabilistic forecasting. Probabilistic forecasting are four types, like a quantile forecast, interval forecast, density, and the scenarios. So we forecast like quantile 95, 90 different quantiles, so it's called the quantile forecast. If you forecast the upper and lower bounds, then it is called the interval forecast. If you forecast the probability density function, so that is called the density forecast. And if you forecast the scenarios, they are random input with the occurrence probability, or that is very that is used in stochastic optimization. So that is called the scenarios forecast. Now, depending types of the problem, depending on very short term, depending on the forecasting horizon and forecasting horizon, the problem may be very short term forecasting, short term, medium term, and long term forecasting. And if you're talking about the error, so obviously error is the very less as very short term forecasting, because the time step is the only few seconds to minutes, and very high in the long term forecasting. Obviously, accuracy is high for the very short term, accuracy low for the long term forecasting. If you're talking about the data resolution, so very short term forecasting data may be 1 minute or 5 minute resolution, and for the day, long term daily, monthly, or yearly. If you have the higher data resolution, obviously the higher more number of data points, and you got the more efficiency or less error or accurate prediction. This is the broad classification of the forecasting model: physical, statistical, and advanced model. Physical model mostly used for the wind and solar power forecasting. It is the numerical weather prediction model. And statistical, the most popular model is the time series model. And nowadays, using the machine learning models fundamentally based on the artificial neural network. There are in the forecasting there are different error matrix also. Just we want to develop any forecasting model, make the forecast and just evaluate the accuracy of the model. So for the deterministic forecasting, we are using the mean absolute error, mean square error, RMSE, mean absolute percentage error. And for similar to the probabilistic forecasting, we are using the analysis score, reliability diagram, sharpness, KS statics, pinball loss function, continuous rank probability score. Now, here we are discussing the detail of time series model. In the time series model, before understanding that like time series, one of the model is the ARIMA model, auto regressive integrated moving average. So before understanding that model, we have to understand some common parameter, that is the autocorrelation function ACF and partial autocorrelation function white noise. ACF is like all been compatible with the correlation between the two data sets. But what is the autocorrelation? It's against the correlation, but not a different data set. It's the same data set, but the another data set is the some lag value. For example, what is the correlation of the YT with YT minus 1, YT with YT minus 2, yt with t minus 3. So their previous values, lag values. So that is called autocorrelation. And this autocorrelation is very helpful to decide what is the order of moving average model. It is used to identify the given data is stage 3 or the non-stage 3. And for the given like a sample size or how many lakhs we have to consider or how many observation we have to require. So to find out the suitable value of the autocorrelation, at least we require the 50 number of the observations or data points. And for the lag almost 3 t by 4, it's a number of the data points by the 4. So one fourth data lag up to we can require to calculate this ACM plot. Now, similar to the partial autocorrelation function, again, it's a correlation. But the difference between the autocorrelation and partial autocorrelation, in partial autocorrelation, we are eliminating the dependency between the intermediate variable we can eliminate. For example, if you calculate the autocorrelation with yt minus 1 and y minus t minus 2. So in yt minus 1 and yt minus 2, we can eliminate the dependency of these intermediate variables. But in autocorrelation, it's already inherently is considered. By default, it's considered, but in partial correlation, we can eliminate. So that is called the partial autocorrelation function. And it is useful to estimate the order of autoregressive model. White noise is the autocorrelation of no correlation. It's a random process. Generally, it follows the Gaussian distribution. It shows that zero correlation, or you can see if there is no correlation, then ACF plot are within the bound. No lag is outside of the limit, except the one by default is for at a zero lag by default one, because what is the correlation of the yt with respect to yt? By default is one, same value, so correlation is the one. So at zero lag it's a one, other lag it's not a one. So for other lag it should be within the limit. Now this is the general procedure to develop any forecasting model. So first of all we define the problem. So what is our forecasting variable? What is the forecasting horizon? That is the short term, very short term, medium term, long term. Then we collect the historical data. Then we can do some data processing, pre-processing. We can take the missing values. Nowadays, the dimension reduction algorithms nowadays we are using to reduce the dimension of the data, like in principal component analysis, we are using to reduce our dimension. Then data analysis part, we can find out the time series component, check the statistic or non-statistic, because most of the time series models are applicable only for the statistic data. Then model fitting, we just estimate what are the order of the model, their unknown parameter we are calculating. So that is definitely it's called the model fitting of the model. Then obviously there are error is also in the parameter estimation, but the estimation error in the parameter estimation should always be less than our forecasting error for the proper model. Then once this is the loop process, when you select the model, then we can validate the model, just input the data, find out the forecast the values, then check the accuracy of the model. When accuracy is justified, then we can deployment of the forecasting model for the customers or for the utilities. Then they also continuously monitoring by using different errors. They evaluating the accuracy of the forecasting model. So this is the general process to develop any forecasting model. Now here I discuss only the time series model. So basically the time series model are four types. Only we are discussing the univariate model, not multivariate. So univariate time series models are autoregressive, moving average. The combination of this autoregressive moving is the ARMA model, and the integrated also features. So ARIMA, auto-regressive integrated moving average. Now, these three models are only applicable in stage data, and otherwise non-stage data also applicable. And to check the converted stage and non-stage data is very simple. We can easily convert the non-stage data to stage data by differentiation or the logarithm transformation. Differentiation can be stabilize the mean value, and logarithm transform can stabilize the variance. What is the meaning of the stage data? If the mean and variance should be constant throughout the time. Suppose I have the 100 data points. I calculate the mean for the first 20, the next 20, the next 20, and variance also first 20, next 20. Then the mean and variance should be like very approximately same or stabilized. Then we call this steady data. If it is increasing, decreasing, not stabilized, then that is a non-steady time series. Now, this is the mathematical formulation of some basic time series model. So first one is the white noise. So you can see here. Check. Yeah. So C is the mean value. We have the historical data. By data, we can calculate this constant term. Mostly that is the mean value. And ET is the random variable. It's a white noise. It's a follow the Gaussian distribution with a zero mean and one standard deviation. So this is the random noise model. So for prediction of this one, just we enter the random value and make the prediction. Now, second one is the random walk. Here, in the first one, you can see we are not using any historical observation. So that is simply white noise. But here we can add one historical observation like to predict the YT. We are using the constant value, historical value, t minus 1 value, just previous value, at the white error. So that is called the random walk. Again, you can see here by default, we are considering the weightage is the 1. But now only one historical observation we consider, just previous only, and weightage is 1. But now in the auto-regressive, you can see the multiple values y t minus 1, t minus 2, t minus 3, previous observation. That depends on the order of the auto-regressive model. Based on the ACF and PSA plot, we estimate the order. So how many previous observation we have to consider. So that is called the auto-regressive. Again, their weightage is not 1. There's 5, 1, 5, 2, and 5, 3. So these are the parameters. We can also estimate the parameters, what are the weightage of these values. So that is the auto-regressive. But here you can see we are not considering the previous errors. But in the moving average, you can see the constant value, error, and the time t, and the previous error with their weightage. So that is called the moving average. And ARIMA is the combination of auto-regressive and the moving average. Or ARIMA, only ARIMA, that is the degree of differentiation is additional component. Otherwise, it is same as ARIMA. And this equation also we can write in terms of the B operator, that is called the backseat operator. Only the repetition is different, otherwise same thing. Now, how we can decide the order? So order of the auto-regressive model we can define by using the PSA plot, moving average is the ACF plot, and ARMA model both ACF and PSA. These are the some set of rules. That is, if the MA plot the ACF plot for the data set, if ACF plot is lags cut off after the lag Q, then order of the moving average is the Q. And PSF is exponential decay or damped sinusoid for this one. For same for the AR, just opposite, and for the ARIMA, both are exponential decay and damped sinusoid. This is the basic ARIMA model code we are developing the R. Install and load the packages, load the data, make the data series tastefully. Then to estimate the order, we are using the auto ARIMA function. But theoretically, they are estimated by this one observation. And We develop the model, ARIMA model, and make the prediction. This is the case study. We are considering three data set, three wind farms. We normalize the data with their installed capacity. So all data points within the range of 0 to 100. Then we plot the ACF and PSCF plot. So all three wind farm, you can see the ACF plot is exponential decay. And you can see they are not a normal distribution continuously fitting. So all the data are the non-Stacy data. Or from the diagram also you can see. So making the data stage 3, we can differentiate. One time differentiation we can do. And after differentiate data again, it's a different data set. Okay. But do the differentiation and make again the plot, then you can see this type of the plot. And you can see the density plot also. So now data is stage 3 data. And for make the prediction, we can by using the auto arima function. Our order is the 5 1 comma 1. It 5 is autoregressive term, 1 for the degree of differentiation, and 1 for the moving average. And we estimate the parameter normally. Generally, some methods are there to estimate the parameters. And in this, like packages also there, so estimate the parameters. Their values are there. There are error in the parameter estimation. And we make the prediction and find out the root RMSE and mean absolute error. And obviously, if you consider seasonal parameter also, because the wind and the load data, they show the seasonality pattern. They are repeated, same repetition for the some seasonal values. So for the seasonal values, if you consider seasonal parameter, so then like load data we have the seasonality pattern. Like the load of the weekdays and the weekends, they are different, or almost same for the same weekends, or like some holidays. Some basic holidays also the load is different. So for that, the seasonal model we can develop, or obviously it show the more better accuracy as compared to the conventional model. I'll show that one R code for this one. Just a minute. Yeah. Uh, First, again, the procedure for that. First, we have to install the suitable packages or called the library. So I installed the forecast package, AST package, read Excel package to read the Excel file, forecast package, including the inbuilt function of this ARIMA function, ARIMA model. So I call just first I call the libraries, library forecast, library statics library read Excel. Then I read the data file from this link X. I read the data from the Excel file. Just I view the data file and define the select the data, particular data, the particular wind farm I select here. Then I'll create the time. We'll create the time series. So TS my data, and then to check the order or stage three to check the stage three, we can plot the ACF plot. So we can calculate the mean value ACF plot. We can plot here. Then by observation we can differentiate the data. Again calculate the mean and check the data is stage three or not. Then to calculate the parameters, we can use the auto ARIMA function. Then seasonality we can also find out. Then it show the order, that is autoregressive 2, moving average 2, seasonality 1 and 1. Then we can develop the ARIMA. We can give the data set, define the order, seasonal data set, seasonal order. Then we can make the forecast, seasonal ARIMA. We can provide the next 24 values we have to forecast. So provide, and here it is a 24 different parameter values. Then to compare our forecasting accuracy, we can again we read the actual values. Suppose I have the 3-year data set. So 2-year data set I can use for the training of the model. 1 year, one data year I can use for the validation. So 2-year data I used for the parameter estimation and the training of the model. And for the validation, again I read the next year data, and we can calculate the error matrices. So this is the very simple program to execute the ARIMA model in the RS Studio. Or I think in the MATLAB, econometric toolbox is there. In economic toolbox, you have this type of the models, ARIMA model and some other advanced models are there. But here, a lot of libraries are there. Machine learning libraries, like a TensorFlow library is also there. So if you learn the basic syntax and how we can import a basic syntax of this platform, you can write. You can able to write the codes, or you can use this platform. We have some time is left, 20 minutes. I can show some. Yeah. Uh, One more important feature, I'll just explain the games. Suppose you just export the data in the Excel file, the different set. So they are not like a suppose I have the data like two sets are there, I and J. So it show the I in the first column, J in the second column, and then data points. It's not like a I in the column and J as a row. It's a J as a I as a row as a J in the column, and these are the data points. Multiple column data set and data points. So if you want this output in this format in Excel, then you can use like this syntax. it's like again it's already inbuilt code. System file this just copy paste. It's available on the games website also. So only use this statement. MS app avail Excel one, then same statement, then and if. So if you run, then you can say you can get the data in this format. Other important thing like condition, you can see they are using the or statement, not or statement. The other statement you can put in the constraint as well as the set or equation you can bound. Uh, yeah, one more important thing in the games. Suppose you want to change the solver. By default, it is solved by the simplex. If I run this code, then you can see by default it is solved by the simplex solver. Okay, now solver. So you can go to the option, go to the solver, then check the LP. LP can also solve by this solver, BARO, Baron, BARON, BARON. So if you want to change, then before the solve statement, type option, type of the problem, LP, BAR, name of the solver. You can see now change, solver has been changed. Now you can see the Baron solver. Now, sometime if you working on the NLP problem, and so sometime it's like a after the maximum iteration, again our problem, your solver show the infeasible result. It failed to converge. So you can also increase the gap, like a gap between the solution and the iteration, like a point, some point gap is already there, so it show the infeasibility. So you can allow that gap in the solver, and also you can increase the number of the iteration also. So that is solar options also available. So for that options you can you have to uh, go to the solver solar manuals. You have to read the solar manuals. There are option other inbuilt like a other file you required, like a progress display level. So these are the multiple functions are there. How you can use you have to read Cortana solution solar manuals. So sometime you have to use some advanced features to execute your code. So you have to go through the solar manual and you can do some modifications. Okay, so now it is close from my side and open for the questions. Any query you can ask. Yes, participant, do you have any query? Mrs. Mita, am I audible?
Yes, sir.
Okay.
If participants have any queries, they can ask, please.
Okay then. Thank you.
Okay, sir. So I am very much thankful to our today's resource person, Dr. Kailash Sharma sir, for sharing his valuable knowledge with us about games. Thank you, sir. We are going to
Thank you.
start our tomorrow's session at 9 a.m. sharp. So I request all the participants to join the same on time for smooth conduction of program. So once again, thank you all. Thank you all
Hello,
participants for their presence.
hello, Miss Smita.
Okay, thank you.
Yes, sir.
Tomorrow, what time? Starting time?
9 a.m., sir.
No, as per the schedule you gave, it says 11:30 to 1:30 and raw algorithms. Correct. I have that with me.
Yes, sir. Yes, sir. 11:30 to 1:30.
Not morning 9.
Yes, sir. Yes, sir. Sorry, sir. On Thursday, 11:30 to 1:30.
Okay, okay. Thank you.
Yes, sir. So once again, thank you all. With the permission of today's resource person, I declare today's session is over.
Okay, thank you very much.
Hello, ma'am. Feedback link, please.
Yes, sir. Yes, ma'am. Okay, thank you all.